Hello everyone, welcome back to ChemOrgChem. If you are new here, don't forget to hit that subscribe button and ring the bell icon. Stay updated with our latest videos. In today's videos, we are exploring the DMAP reagent. We will cover the preparation, basicity, and application along with the mechanism with 40 diverse examples to solidify your understanding. So let's get started. First, let's discuss what DMAP. DMAP stands for 4N-Dimethylamino pyridine. So it is a derivative of pyridine with a dimethyl amino group attached to the fourth position of the pyridine ring system. Let's moving on how to prepare DMAP reagent. There are several routes are available to prepare the DMAP reagent. However, here we are going to see only the two routes. So let's see one by one. So the first route involving the reaction with pyridine and chlorine that produce this intermediate. This intermediate readily react with dimethylamine to produce this corresponding DMAP reagent. So instead of chlorine gas, if you use thionyl chloride, that also produce the similar intermediate which readily react with dimethylamine to produce this corresponding DMAP reagent. Next, moving on the basicity of DMAP. DMAP acts as a Lewis base. So now you look the DMAP structure. There are two nitrogen atoms having the lone pair of electrons. So now we should see which nitrogen atom could give the lone pair of electron readily. So for this, you just consider the reaction of DMAP with acid. So now you imagine that, so this nitrogen react with acid that readily produce this corresponding conjugate acid. In other hand, if this nitrogen atom react with acid that readily produce this corresponding conjugate acid. So now we should see which conjugate acid is more stable. More stable the conjugate acid, the more basic and nitrogen atom. So or otherwise that nitrogen atom is more nucleophilic nitrogen. So now you consider this conjugate acid. So this conjugate acid is stabilized by resonance. So now you see this electron shifted here, this electron shifted here, then followed by this electron move towards the nitrogen atom that generate this resonance stabilized conjugate acid. So when you come to this conjugate acid is cannot stabilize by resonance. So based on that, this nitrogen atom is more basic as well as more nucleophilic nitrogen atom. And when you compare to the pyridine, DMAP is a stronger base. So we can easily see by the pKa value. The DMAP pKa value is 9.2 while the pyridine pKa value is 5.2. The higher pKa value indicates that so DMAP acts as a more basic when compared to the pyridine, which is due to the electron donating effect of the dimethyl amino group, which increases the electron density on the nitrogen atom of this pyridine ring system. This increases the nucleophilicity of this nitrogen atom in the pyridine ring, making a DMAP a more effective base when compared to the other common organic bases such as triethylamine. DMAP aromatic nature and resonance stabilization make it a unique and efficient catalyst for some of the specific reactions. Next, moving on the applications of DMAP. So DMAP can be useful for variety of reaction. However, here we are going to see some of the application such as DMAP act as a nucleophilic catalyst, and DMAP can be useful for Steglich Esterification, Yamaguchi Esterification, Shina Esterification, as well as amide coupling reaction. So let's see one by one how DMAP reagent could useful for this variety of transformation. First, we are going to see the acylation reaction where DMAP acts as a nucleophilic catalyst. So these acyl producing groups are generally used for the production of hydroxy or amino groups. So acetyl, benzyl, pivalyl groups are generally used for the strategy to installing the acyl producing groups. So acyl groups are stable under acidic and oxidative conditions. When you come to the deproduction, basic or reductive conditions such as dipole H, LAH can be useful for deproduction of acetyl groups. So now you see how acylation reaction takes place in the presence of DMAP as a nucleophilic catalyst. So when you take the alcohol or amine, when it react with acetic anhydride or acetyl chloride in the presence of DMAP and triethylamine and dichloromethane medium, which readily produce this corresponding acylated product. Let's moving on the mechanism. So initially DMAP react with acetic anhydride. Now you see acetic anhydride has two carbonyl carbon. So our DMAP readily react with one of the carbonyl carbon to produce this corresponding acyl dimethyl aminopyridine cation as a intermediate. So which readily react with alcohol. So now we can take the alcohol as one of the example. So now you see this alcohol lone pair of electron which readily attack this carbonyl carbon, which leads to generate this corresponding tetrahedral intermediate. So now you see triethylamine which readily abstract this hydrogen, then followed by, so this negative charge move towards here, then followed by kick of DMAP which readily produce this corresponding acylator product along with DMAP as well as these byproducts. So let's see some of the examples for acylation reaction. So here you see the first reaction which involving the 2,4,6 trimethylphenol react with acetic anhydride and DMAP here act as a nucleophilic catalyst to produce this corresponding acylator product. So this is the another example, benzyl alcohol react with acetic anhydride and DMAP in the dichloromethane condition which produce this corresponding acetylator product. So this is the another example. So now you see this primary alcohol which readily produced by acetic anhydride in the presence of DMAP and pyridine conditions. So here you see instead of triethylamine we can use the pyridine also. In some cases they used only DMAP. That means that in this reaction they used excess of DMAP for this particular case. This is the another example. So indole react with acetic anhydride and DMAP which readily produce this corresponding acetylator product. So this is the another example. So now you see, so this compound having alcohol as well as secondary amine group, both are readily protected by using acetic anhydride and DMAP condition which produce this corresponding product. So this is the another example. So just like acetic anhydride or acetyl chloride, so when you take the benzoyl chloride in the presence of DMAP, which readily produce this corresponding benzoylator product. So let's moving on the next one as a Bock production. So where the DMAP act as a nucleophilic catalyst. So especially secondary amine, when you take the Bock anhydride in the presence of DMAP and suitable solvent, which readily produce this corresponding Bock products, and along with carbon dioxide and tertiary butanol as a byproduct. So let's see the mechanism. So initially DMAP react with Bock anhydride to produce this corresponding intermediate, this active intermediate which readily react with secondary amine to produce this corresponding tetrahedral intermediate. So now you see, so this anion which readily takes this hydrogen, then followed by this negative charge moves here, then followed by kick of DMAP which readily produce this corresponding Bock producted amine. So at the same time here you see, so this compound is not stable, so which readily decompose to produce carbon dioxide as well as tertiary butanol as a byproduct. Let's see some of the examples for Bock production. So when you take the pyrrole react with Bock anhydride in the presence of DMAP which produce this corresponding Bock producted pyrrole as a product. So this is the another example. So when you take the primary amine which readily produce this corresponding double Bock producted amino product. So this is the another example when you take the cyclic lactam. So this cyclic lactam which readily producted by using Bock anhydride in the presence of DMAP. So this is the another example. So now you see this amine which readily producted by Bock anhydride in the presence of DMAP which produces corresponding product. And similarly this one also amide NH when you treat with Bock anhydride in the presence of DMAP which produces this corresponding product. And just like amine, so alcohol also can be produced by Bock group. So now you see this is the isopropyl version in the presence of DMAP which readily produce this corresponding producted alcohol. So let's moving on another example where the DMAP acts as a nucleophilic catalyst for the tosylation reaction. So for tosylation, so you can take either alcohol or amine react with sulfonyl chloride, either alkyl or aryl sulfonyl chloride in the presence of DMAP triethylamine which readily produce this corresponding sulfonylator product. So let's see the mechanism. So initially DMAP react with aryl or alkyl sulfonyl chloride, which readily produce this corresponding active intermediate. This active intermediate react with amine or alcohol. So now you see this lone pair of electron attack the sulfur atom, which readily produce this intermediate. So now triethylamine, which readily abstract this proton, and followed by this negative charge move towards to the sulfur atom, then followed by kick of DMAP, which readily produce the sulfonylator product. So let's see some of the examples. So here you see, so when you take the aniline with para-toluene sulfonyl chloride in the presence of DMAP and triethylamine, which readily produce this corresponding tosylator product. And similarly, when you take the phenol, that also readily produces corresponding tosylated phenol derivative. And when you take the benzylamine or benzyl alcohol, which readily produce this corresponding tosylated amine as well as tosylated alcohol product. So this is the another example. Instead of using alkyl or aryl sulfonyl chloride, when you take the trifolic anhydride, so this one also which readily produce this corresponding trifolated product. Next, moving on, another example where DMAP act as a nucleophilic catalyst for silylation reaction. Silyl group, one of the most commonly used protecting groups for hydroxy functional groups. So here there are several silyl chloride can be useful for this reaction. So now you see, so when you take the alcohol, react with either alkyl or aryl silyl chloride, when you use DMAP and triethylamine reaction condition, which readily produce this corresponding silylator product. So let's see the mechanism. So first, DMAP react with this aryl or alkyl silyl chloride, which readily produce this corresponding active intermediate. So now you see alcohol, which readily react with this active intermediate. So now you see this oxygen atom attack the silyl group, then followed by kick off DMAP, so which readily produce this corresponding intermediate. So now you see this triethylamine readily abstract this hydrogen, which readily produce this corresponding silylator product. So let's moving on some of the examples for this reaction. So I already said there are several silyl based reagents are known for this reaction, for such as trimethyl silyl chloride, triethyl silyl chloride, TPS chloride, and TPTPS chloride. So now you see first example. So when you take this alcohol, react with trimethyl silyl chloride and DMAP, which readily produce this corresponding product. And similarly, when you take this alcohol, react with a TPS chloride, which readily produce this corresponding TPS protected alcohol derivative. And here you see triethyl silyl chloride also useful for this reaction. Here you see when you take this alcohol, triethyl silyl chloride and imidazole reaction condition, which readily produce this corresponding TES protected alcohol. Here imidazole just played a similar role as triethylamine. So let's see some of the other examples. So here you see this example is one of the interesting examples, since this compound having both primary as well as secondary alcohol, when you react with a TPS chloride in the presence of DMAP triethylamine, which readily protected this primary alcohol group, since this TPS chloride is a bulky reagent, so therefore which selectively react with primary alcohol. So this is the another example. Now you see, so this sugar derivative has primary alcohol as well as secondary alcohols. However, when you treat with the TPTPS chloride, which selectively product this primary alcohol groups due to the steric effect. Let's moving on. Another example. So where DMAP acts as a nucleophilic catalyst for tritylation reaction. So tritylation is mainly useful for the production of alcohol. So they can selectively product for sterically less hindered site, just like our silylation reaction. So now you see when you take the alcohol, react with trityl chloride in the presence of DMAP triethylamine, which readily produce this corresponding tritylated alcohol derivative. So now you see the mechanism. So initially, DMAP react with trityl chloride, so which readily produce this corresponding intermediate. So now alcohol react with this carbon center, then followed by kick of DMAP, which readily produce this corresponding intermediate. Now triethylamine readily abstract this hydrogen to produce this corresponding tritylated product. Let's see some of the examples. So here you see when you take this alcohol, react with trityl chloride in the triethylamine DMAP condition, which readily produce this corresponding product. So this is the another example when you take the benzyl alcohol trityl chloride in the presence of DMAP, which readily produce this corresponding tritylated product. So this is the another example. Now you look, so here you see one primary alcohol unit as well as 3 secondary alcohol. However, our trityl chloride selectively react with this primary alcohol to produce this corresponding product. Next, we are going to see Steglich esterification, where DMAP acts as a catalyst for this esterification reaction. According to this reaction, when you take the carboxylic acid and alcohol in the presence of DCC and DMAP reaction condition, which readily produce this corresponding ester product. So here DCC means that dicyclohexyl carbodiamide. So where DMAP acts as a catalyst and DCC acts as a coupling agent to activate the carboxylic acid. So for mechanism, we have already discussed mechanism in our channel. If you missed to watch, don't worry, you can find the link from description box. So just like Steglich esterification, so another reaction is Heck-Magro-lactonization reaction, where DMAP acts as a catalyst for this Magro-lactonization reaction. So now you see this reaction. So here you see this reaction is just intramolecular version for Steglich esterification. However, here we need extra DMAP hydrochloride reagent for this reaction, which readily produce this corresponding lactone product. So this Heck-Magro-lactonization reaction also we have already discussed in our channel. So you can find the link from our description box. So next, moving on, some of the examples are based on Steglich as well as Heck-Magro-lactonization reaction. So now you see this sugar derivative react with chloroacetic acid in the presence of DCC DMAP, which readily produces corresponding ester product. So this is the another example when you take the keto acid react with this phenol derivative in the presence of DCC DMAP, which readily produce this corresponding ester product. So this is the another example. So here you see instead of using DCC, we can use the EDC hydrochloride also. So here you see this acid which readily react with tertiary butanol in the presence of DMAP, which readily produce this corresponding tertiary butyl ester. So this particular reaction is important since when you see the Fischer esterification reaction, we can't easily prepare this corresponding tertiary butyl ester, since when you use Fischer esterification reaction condition, this tertiary butanol readily dehydrated to produce this corresponding alkene product. We never get this corresponding tertiary butyl ester product. So this is the another example for Heck-Magro-lactonization reaction. So now you say this intramolecular reaction which readily produces corresponding lactone product. This is another example as well as interesting example also. So now you say this compound has two hydroxy group. One is secondary, another one is tertiary. However, this carboxylic acid preferentially react with secondary alcohol due to the steric effect, which readily produce this corresponding ester product. Next, moving on, Yamaguchi esterification. So according to Yamaguchi esterification reaction, when you take the carboxylic acid react with Yamaguchi reagent, which readily produce this corresponding mixed anhydride. This mixed anhydride react with alcohol in the presence of DMAP, which readily produce this corresponding ester product. This mechanism also we have already discussed in our channel. So you just find the link from description box, whoever missed to watch our Yamaguchi esterification reaction. So here you see some of the examples for Yamaguchi esterification. So Yamaguchi esterification, we can carry out intermolecular, intramolecular, as well as dimerization reaction. So in all the cases, DMAP acts as a catalyst for this reaction. So now you see first reaction, when you take this carboxylic acid as well as this alcohol derivative, which readily react in the presence of DMAP, which readily produces corresponding ester. So this is the intramolecular coupling reaction. So now you see this substrate has hydroxy as well as carboxylic acid in the same molecule. TCPC means trichlorobenzyl chloride in the presence of diisopropyl ethylamine and DMAP, which readily produce this corresponding lactone product. And similarly, dimerization also possible. Here you see this substrate readily dimerized in the presence of Yamaguchi reaction condition which produce this corresponding lactone product. So next moving on, Shina esterification reaction. So this reaction just like Yamaguchi esterification. So instead of using Yamaguchi reagent here, if we use Shina reagent means that 2-methyl-6-nitrobenzoic anhydride is called Shina reagent. So just similar to our previous reaction that produce corresponding ester product. So this reaction mechanism also we have already discussed in our channel. You can find the link from description box whoever missed to watch our Shina esterification reaction. Let's see some of the examples are based on Shina esterification reaction. Now you see, so this Shina esterification reaction condition, this hydroxycarboxylic acid which readily undergo lactonization reaction to produce this corresponding product. And similarly, four-membered lactone ring also possible under Shina esterification reaction condition which readily produces corresponding lactone product. In all the cases, DMAP acts as a catalyst for this reaction. Just like intramolecular reaction, intermolecular reaction also possible by Shina esterification reaction to produce this corresponding product. So next moving on, our final application for DMAP as a amide coupling reaction. So according to this reaction, when you take the carboxylic acid amine in the presence of EDC hydrochloride and DMAP, which readily produce this corresponding amide product. So here EDC hydrochloride acts as a carboxylic acid activating agent. So let's see mechanism. So initially carboxylic acid react with EDC hydrochloride, which readily produce this corresponding protonated intermediate. So now you see due to the protonation, this carbon center is electron deficient. Therefore, this acetate ion readily react with this intermediate, which readily produce this corresponding intermediate. So the intermediate readily react with the DMAP. So now you see this DMAP nitrogen, which readily attack this carbonyl carbon. So which resulting that to produce this corresponding acylated dimethylamino cation as an intermediate along with this urea byproduct. This acylated intermediate which readily react with amine. So here you see how this happened. So this electron attack here, then followed by kick of DMAP, which readily produce this corresponding amide product. So let's see some of the examples based on amide coupling. So now you see this carboxylic acid react with this amine derivative in the presence of EDC DMAP, which readily produce this corresponding amide product. And similarly, this carboxylic acid react with the secondary amine in the presence of EDC DMAP, which readily produce this corresponding amide product. So this is the another example when you take the 2-bromoaniline react with this acid derivative in the presence of EDC DMAP, which readily produce this corresponding amide product. And similarly, when you take this carboxylic acid, this amine in the presence of DMAP and EDC reaction condition, which readily produce its corresponding amide product. To summarize, today we have covered DMAP reagent and their preparation, basicity, and their important applications as a nucleophilic catalyst and some of the esterification reaction. And finally, we have covered the how DMAP can be useful for amide coupling reaction. If you found this video helpful, please give it a thumbs up and don't forget to share it with your friends. Make sure to subscribe and hit the bell icon so you never miss any update from ChemOrgChem. So here you see, you can find some of the practice problem when you get the free time, you just give it a try. And finally, thanks for watching and bye-bye.